Just to finish off this process, let's also complete cosine of 30. Who can help me with cosine of 30? Again, we do the same thing each time, right? So cosine tells me adjacent over hypotenuse. I go to 30, I find adjacent, that's radical 3, and I go to hypotenuse, that's 2. So our cosine of 30 is radical 3 over 2. Excellent. Okay, any questions so far? Let me be perfectly clear because the vocabulary we use on the exam is very important. So I want you guys to be very comfortable with the words that I'm using to describe the different sides of the triangle, right? So the side that is across the 90 degrees, so here's our 90-degree angle, right? My little box. This side is always referred to as the hypotenuse in a right triangle. It is the longest side of the triangle. So you go across 90 degrees, that is always your hypotenuse, and that is always the longest in any triangle, the largest side, always. So that vocabulary is very, very important for you guys to understand. And the other vocabulary, adjacent or opposite, is relative to the angle. So if we are looking at 30 degrees, opposite to 30 degrees is this one over here. The one that's not forming the angle is opposite. So you see these two are forming the angle opposite. This side is opposite to 30 degrees. This side is the hypotenuse always, and that leaves this last side adjacent. So if we're looking at 60 degrees, this becomes my opposite. This is my adjacent, and my hypotenuse is still 2. Okay. Any questions, you guys, on the first one? Again, we didn't have to do all of this just to answer this question. This question could simply be answered if you guys memorize this idea that sine of whatever angle is equal to cosine times 90 minus that angle. So for example, you see that sine of 30, cosine of 60 is equal. These two add up to 90. So anytime those angles add up to 90, their sines and cosines will be equal. So that is kind of the shortcut. But again, I want to over teach in this webinar. I want you guys to be really comfortable with all these concepts, because even though this simple idea could have answered this question, in other questions, you might actually need to draw out the triangle and you might need to know these ratios. So it's good practice, okay? All right, anybody have any questions? No? Okay, let's tackle number 2. So we have a diagram. So almost immediately when on the geometry exam, I see a figure like this, what are you guys thinking? What concept are they most likely going to be testing here? What pops into your head? So before I even think of anything, I think probably they're testing me on similar triangles. So in order to be excellent test takers, which I know you guys are all capable of being, you want to get really good at thinking like the test maker. You have to think, what does the test maker want from me, right? Like if I was writing this question and I'm part of the Common Core curriculum and I'm doing the geometry Regents, what concept that I've learned in class or that I'm teaching in class am I trying to test, right? So once you guys have enough practice, even before looking at the question, you'll notice some sort of patterns and similarities. So this figure to me is screaming similar triangle type of question. It's screaming that most likely I'm going to have to set up a ratio and find out a missing side, right? That's what is my sort of, test tuition or intuition, as I like to call it. We're not 100% sure. We're always going to read the question, but I want to start introducing that idea for you guys to just start developing your test intuition skills because it helps tremendously. Okay, so now let's see what they really want. We have a diagram of a triangle, SRA. Here's our triangle. They're telling us that SKP, so I'm going to label, is equal to SRA. So here are my two equal angles, right? Now, angle S is equal in both the triangles because they share it, and that means that this third angle must be equal, right? Because in any triangle, all the angles add up to 180. So if we have two angles that are the same, it implies that the last angle is also the same. So basically, in that one statement, we just prove that these two triangles are similar triangles. Now we label all the sides. They tell me SK is 10. They tell me SP is 8. They tell me PA is 6, meaning this whole side is going to be 14. and they want this missing piece. Okay, so who's going to set up my proportion for me? We've got similar triangles, so that's already half the battle. We need to set up a proportion. Now we have to think which sides are proportional to which side. So SP, it's going to go SK over SR is equal to SP over SA. Does that make sense to everybody? The small triangle is proportional to that bigger side on the right side, and on the left side, the small triangle is proportional to that bigger side. And now all you have to do is you have to plug in the values, right? So instead of SK, we have 10. Instead of SR, we represent this whole side with the sum, 10 plus X. And then that's going to be equivalent to, on our right side, 8 over 14. Excellent. This is exactly how you set it up. For the people that flipped it, it's absolutely identical to do it the other way. So you could also say like 10 is equal to 10 plus X over 8 is equal to 14. That's completely fine too. And both of these are equivalent. And the reason I know that is because at the end of the day, how do we solve this proportion? We must cross multiply, right? And whether you set it up the first way or the second way, when you cross multiply, you end up with the same means and extremes, right? The things that multiply, that's the important part. You end up with the same answer. So now let's go ahead and simplify this, right? So we're going to have 10 times 14 is equal to 8 times 10 plus X. Now, this is the part where students can mess up a little bit. Do not forget, anytime you have a sum in proportions, do not forget to put parentheses around it. You must, because if you forget to put parentheses around it, you'll mess up. You'll only distribute the 8 to the 10. You'll forget to distribute it to the X, and you'll get a wrong answer, even though you set everything up correctly. Okay, so parentheses, then we solve. 140 is equal to 80 plus 8x. I'm going to subtract 80 from both sides. I'm going to end up with 60 is equal to 8x. And then the last step, dividing both sides by 8. And we're going to get x is 7.5, right? 7 times 8 is 56. So we end up with 4 out of 8 of a remainder, and 4/8 is just a half. So here is our answer. Okay, any questions on the second page, guys? Nope? Okay, let's keep going. Okay, we've got number 3. A rectangle is graphed on the set of axes below. And the question is, a reflection over which line would carry the rectangle onto itself? All right, guys, how are we tackling this one? Who can tell me what this line looks like? Y equals 2 or y equals 10? How would you describe these lines? Either one of these. Flat line, correct. Is it horizontal or vertical? Horizontal, excellent. So both of these are horizontal lines. So my technique for this question would be, it's easiest to start here, right? Because these horizontal lines are easy. I don't have to deal with the y-intercept. I don't have to deal with the slope and think about it, if that makes sense, and reflect it over a diagonal. So let's start with these easy lines and see if either of these carry the rectangle onto itself. And if it does, then that's it, we're done, right? So let's start with, let's say y equals 2, right? So we're going to have a horizontal line, like you guys said, straight across, and it goes through 2, right? That's why I drew it here. So this is 2. And the way you prove it to yourself is you think of any point on this line, right? Like let's say right here, or let's say right here, right? This point is 0, 2. This point is 1, 2, 3, 4, 2, right? This will be 7, 2. So you guys, any number, any point on this line, the y value is always 2, right? That's why the line is y equals 2. Okay, so now imagine reflecting this rectangle across this line. So how do we reflect it, right? Let's say we have a point, this point, right? This point is 1, 2, 3, 4 down. So if I reflect this point across this line, I would now have to go 1, 2, 3, 4 up. Does that make sense? Now we'll do the next point. This original point was 1, 2, 3, 4 up. So now I'm going to go 1, 2, 3, 4 down. You see, the rectangle is flipping exactly onto itself. So the first one we tried is our answer. Does that make sense? When I reflected the top point, I ended up on the bottom point. When I reflected the bottom point, I ended up on the top point. And that makes sense because at y equals 2, we cut the rectangle exactly in half, right? We've got 4 units this way and 4 units this way. So when we reflect across that line, the rectangle just carries onto itself. Is everybody okay with these concepts? Anything here confusing, either about how we figured out how to draw that line or how do we reflect the rectangle? No, you guys are good? How do you reflect diagonally? It's very complicated. When you reflect diagonally, like let's say that you were going to reflect across this line. For each point, you have to think about how far, like this, let's say you wanted to reflect this point, right? Technically, you would have to get this distance away from this line, and then you would have to reflect that point exactly on the other like that same distance on the opposite side. It's a little bit beyond what you guys need to know, and that's why again, test smarter, not harder. I would not begin with these, right? Most likely, I knew right away those were not going to be my answer. Yeah, you have to make a triangle from the line, exactly, and then you reflect diagonally. But it's a little bit beyond the geometry regents, and again, work smarter, not harder. We wouldn't necessarily even attempt these unless there's something very weird going on and the answer choice isn't working out. Okay, moving on to our next question. We have the surface of the roof of a house is modeled by 2 congruent rectangles with dimensions of 40 by 16, and they drew these out for us. Roofing shingles are sold in bundles. Each bundle covers 33 1/3 square feet. What is the minimum number of bundles that must be purchased to completely cover both rectangular sides of the roof? Okay, how are we tackling this one? Yep, find the area. So how do I find the area? Yeah, it's rectangle, right? So it's just length times width. So we're gonna have area is length. Oops, that's supposed to be an L, length times width, which is just 16 times 40. But be careful because we got to multiply it by 2 because we've got 2 of them, right? We've got 2 equivalent, 2 congruent rectangles, right? So you got to just read carefully. They show you visually also, right? 1 and 2. The second picture might be a little bit misleading if you just look at that quickly. So we've got 16 times 40 times 2. So 16 times 2 is 32, times 4 is 68. 64, sorry, so 640, and then times 2, 1280. Excellent. So our area here is 1280 feet squared. Now, another kind of tip for the Regents exam, any exam that you take, is be really careful with your units, right? So just double check that this is in feet, double check that this is in feet, right? So everything is the same. Make sure that they are not adding an extra step for you guys where you'd have to convert. Okay, so we've got 1,280 feet squared. But what else do I have to do to complete this question, to answer this question? Yeah, we got to divide, right? The last step. So we have to divide that by 33 1/3. So 12 80 divided by 33.3. And we end up with 38.4. And we have to round up. Does that make sense? Because they want the minimum number of bundles that we can buy. We can't buy 0.4 of a bundle. And if we just buy 38, it's not enough. So we must round up to 39. And that's the correct answer here, choice 3. All right. Moving on to number 5, we have which equation represents a line that is perpendicular to the line whose equation is the following? Okay, what do we know about perpendicular lines? Let's review. What is the relationship of slopes in perpendicular lines? Yeah, flipped. What does that mean? Use math terms. Yeah, I can see all of your guys' comments. Everybody in the chat? Yeah, negative reciprocal. Excellent. So perpendicular lines have slopes that are negative reciprocals. So what that means in real life is that we flip our numerator and denominator, and we flip our sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Side question, what about parallel lines? What's the relationship of their slopes? Yeah, parallel lines have equal slopes. Good. So these two things must be memorized for your Regents. Perpendicular lines have slopes that are negative reciprocals. Parallel lines have same slope, same slopes. Okay, great. So now they're giving us this line, a little extra step for us, because in order for us to easily see the slope, we want it to be in this format, right? mx plus b. So we have to manipulate this a little bit. I'm just going to move the 3x to the other side by adding it. So this ends up being y equals 3x plus 4. So what's my slope here? 3. Good. Here's my slope. So now I have to flip it and negate it. So just looking at the options, any ones with a positive slope are goodbye, right? Positive slope, goodbye, positive slope, goodbye. And whole slope is also goodbye, right? Because we need to flip 3, so it has to be a fraction. So goodbye. So by process of elimination, this line is going to be perpendicular. So we take 3 over 1, we flip, we get 1 over 3, and then we negate, and we get negative 1 over 3, and that is our slope. Now, our y-intercept does not matter, right? So there's an infinite amount of lines that are perpendicular. So it could be y equals negative 1/3 x plus 17, y equals negative 1/3 x minus 7,945, y equals negative 1/3 x, just like that. Y equals negative 1/3 x plus 1/4. It absolutely doesn't matter what your y-intercept is. Only the slope matters when they ask you about parallel and perpendicular lines. So all of these that I just made up off the top of my head are all perpendicular to our original line, only because the slope in all of these cases is negative 1/3. Does that make sense? And since we reviewed parallel lines, which choice, I know I already crossed it out, but if you guys can see through my X's, which choice in this case would have been parallel? Would have been a line that's parallel to our original. 4, excellent, right? Because the slope there is 3. Good. Choice 4. Not choice 3, it's negative 3 in choice 3. Maybe you didn't see that I crossed it out. All right, guys, great job so far. Let's keep going. So we've got a vertical mine shaft is modeled in the diagram below. At a point on the ground 50 feet from the top of the mine, a ventilation angle is dug at an angle of 47 degrees. And they want the length of the tunnel. Okay, how are we figuring this one out? Yeah, sure. Here. You want to see the notes from above or below? How are we figuring out number 6? At least the concept. What do you guys think that we'd have to use to figure it out? Okay, somebody gave a good suggestion. They said a squared, b squared plus c squared. So let's think about that, right? A squared plus b squared equals c squared. Okay, it's a good idea, right? We've got 50, but we've got nothing else. So we don't have enough we don't have enough to do Pythagorean theorem. We don't have enough information. So it was a good idea, but not quite. What do we have to do instead? What ratios did we learn in the beginning of the class that maybe we could use here? Yeah, right? SOHCAHTOA, good. So now let's figure out which ones out of these are helpful for me here, right? So let me just rewrite our ratios just to review, right? SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? Those are our ratios. Okay, so now out of the information given, which one do you think that we'd use in this case? Yeah, cosine, right? That's the information we have. So how do I prove it to you guys? We have this angle, right? In reference to this angle, what is 50 degrees? Is it adjacent, is it opposite, or is it the hypotenuse? Adjacent, good. So in reference to 47 degrees, the value that we have is adjacent, and the value that we want is the tunnel, and this is our hypotenuse. And again, I'm going to repeat myself. I know this is the hypotenuse because hypotenuse is always across 90 degrees, right? So I have adjacent and I want hypotenuse. So the values that I'm working with is adjacent and hypotenuse, which is how I know that I should most likely use cosine here. You could use sine and then you'd figure out the length of the line and then you could do Pythagorean theorem and figure out the tunnel, but that's extra work for you guys. To originally like get the answer in the shortest amount of steps, we want to use cosine here. Okay, so now we would set it up and we would say cosine 47 is equal to 50 over the tunnel, which is what we want to solve for. And then you just plug this into the calculator to solve, to keep going, right? Because 47 isn't one of those angles that we know, like 45 or 30 or 60. So you'd have to plug in cosine 47 into your graphing calculator and then solve this little mini equation. And once you do that, you get 73. And again, let's just think really quick about logic, right? I told you guys that the hypotenuse is always the longest side. So if I had no idea what I was doing for this question, what I know is that nobody listening to my webinar is going to guess 1 because 1 does not make sense. Does that make sense? We would need it to be greater than 50. The hypotenuse must be the greatest side of the triangle. So even if I don't know what to do here, I would eliminate 1. And at least now my guess is, I have a 1/3 chance of guessing instead of a 1/4 chance, 33% instead of 25%. So always be smarter. Even if you're making a guess, there's usually at least one answer you can eliminate and you can make a smart guess. Does that make sense? So and it cannot be anything less than 50. In this case, we can only eliminate 47. Does that make sense to everybody? Okay. We've got the next one. So we have a set of axes here. They labeled the points for us. So we've got B at -3, -2. We've got L at -2, 5. And we've got U at 1, 1. And they want the area of BLU. Okay, so there's a few ways that we can sort of approach this one. What would you guys do? How are we going to get the area of this triangle? That's a good idea. So somebody said box the triangle. Sure, we can do that. So I can draw out the box for you. Okay, and then what would you do? Yeah, that's a good idea. So somebody said, let's find the area of our box. So we're going to have 1, 2, 3, 4. And then we're going to have 1, 2, 3, 4, 5, 6, 7, 7. So the area of our box, length times width, that's going to be 28. And now I can figure out the areas of all these little triangles, right? Because they're less annoying, like they're clear, right? This is clearly 1, and this is 1, 2, 3, 4, 5, 6. And this one is 1, 2, 3 by 1, 2, 3, 4. And then finally, this last one are 1, 2, 3, 4, 1, 2, 3, right? 4 by 3. So now we can get the areas of all the little triangles. So we have, what's the formula for area of a triangle again? Yeah, right. 1/2 base times height. Good. 1/2 base times height. So we're going to have 1/2 6 times 1. And then we're going to have 1/2 4 times 3. And then we're going to have 1/2 4 times 3. So we have 3, we have 6, and we have 6. So in total, we've got 15. So finally, we can take 28 minus 15. And we end up with 13. Maybe I messed up somewhere. Maybe this is just, oh, this was maybe just a half over here. Oh, this is 7. I just miscounted. This is 1 by 1, 2, 3, 4, 5, 6, 7. Yep, that's why we got it wrong. So this would be 1/2 7 times 1, 3.5. And then we would do minus 15.5, and then to get the right answer of 12.5. So yeah, this is a really excellent technique to box in the triangle. Anybody that hasn't thought of that before. The other way to do this is that somebody said it before, is you would have to do distance formula, and you could figure out like the length of all these values, the length of all the sides. And then you would have to create like a height, right? Because we can't just do it this way. We'd have to create a perpendicular height, which would be quite complicated in this case. Whichever one you choose, I guess maybe the simplest way would be like the height would be something like this. But it would have to be perpendicular. That would be very complicated in this case to figure out what the height is, to figure out the point correctly. So I think the best technique for this would be boxing in the triangle. So this is a really, really good technique to do it quickly. If you're really stuck on a question like this, you have no idea what to do, which you won't be because now we have this technique of boxing the triangle. But if you were, you could try your best to sort of estimate and guesstimate, right? Like this is clearly just 1 unit. 2 units, 3 units, and then you can start like, call this 4, call this, and like try to add it up that way. Not the best technique. It's very hard to get an accurate answer that way. The best way is to box in the triangle. And yeah, somebody said the point is that the rest of the triangles become right triangles. And the reason that is valuable in our case is because then we don't have to find a height, right? Because they're already perpendicular. And then we can easily just use 1/2 base times height versus that middle triangle, which is not a right triangle. There's no way for us to figure out the height in an efficient way. Does that make sense? That's why it's valuable that those 3 triangles are right triangles, because we can just use that formula. All right, guys. Excellent job. Let's move on to number 8. So we have in the diagram below, CAR is mapped onto BUS after a sequence of rigid motions. If AR is 3x plus 4, RC is 5x minus 10, and CA is 2x plus 6, and SB is 4x minus 4. What is the length of SB? Okay, what are they saying here? What is the relationship between these two triangles? What does this mean? Like if CAR is mapped onto BUS, what are they actually doing? They took this triangle CAR and what do they do to it? So what happened is they took this triangle CAR and they rotated it. Exactly. So now we have to figure out which sides are proportional to which sides. And the biggest way to like figure it out for me, or the easiest way, is to just use the name, right? So CAR in that order, BUS in that order. So what that means is that CA, and I'll highlight it for us, so for our visual learners, right? CA is going to be proportional to BU, right? And then we look at the next one, that's AR. That's going to be proportional to US. So AR is this side is proportional to US. And that leaves our last side as CR, which would then have to be proportional to BS, right? So these sides that I just, visually color-coded for us, those are equivalent, right? Because these are not just similar triangles, these are congruent triangles. They took this triangle CAR and all they did was they flipped it. And it could look different, it could not be drawn to scale, whatever it is, but it's the same exact triangle. So in order to figure out the length of SB, we just equate it to the side that it's equal to, which we just figured out as CR. So what will my equation look like? It will look like 5x minus 10 is equal to 4x minus 4. And this is the easy part. All I have to do is solve. So 4x minus 4x, I end up with 1x minus 10 is equal to negative 4. Add 10 to both sides. Okay, x is 6. Are we done? Can I pick one and move on and be happy with my life? No. You have to be really careful with these questions. We have to see what you always have to reread the question at the end. Like you guys will know all the math, all the geometry, and you'll make a silly mistake just because you're not answering the question they want. They don't want X, they want the length of SB. So we have one more extra step. So we have to take this X, we plug it in here to get the full length of SB. So SB is equal to 4x minus 4. SB is equal to 4 times 6 minus 4. SB is equal to 24 minus 4, or 20, which is our final and correct answer, okay? So look, they make 6 choice 1 on purpose, right? Because you guys are so excited, you're done, X is 6, and you look and it's the first thing you see and you circle it and you move on and you feel, good. Be really, really cognizant, right? This is a really common sort of trick that test makers do. They put that false answer choice as choice 1. Does not mean that 1 is never the answer, right? Sometimes 1 is the answer, but just be extra cognizant, right? Before you pick choice 1, just take that extra second to reread the question. Make sure you're answering what they're asking you to answer, so you don't make this kind of silly mistake. Okay. Next one. Again, 2 triangles, right? So we see a lot of themes on this geometry Regents, and this seems to me like it's another one that's likely just testing similar triangles. So now let's read it and prove it. They take this triangle and they just dilate it by a scale of 1/2, right? So they make it 1/2 smaller. So these 2 triangles, by definition, based on what they just told us in the question, these are similar triangles. What do we know about angles of similar triangles? Yeah, the angles are the same, right? So in similar triangles, they have all angles congruent. And their sides are obviously proportional, right? Just to complete our notes. So absolutely, this one's rather easy. If DFC is 40 degrees, then its proportional angle HJG is also 40 degrees, right? By definition, they must stay the same. So the answer is 40. And look what they're doing, right? It's dilated by a scale of 1/2. So a lot of people might be tempted to pick 1, right? Because 20 degrees is half of 40. So you see that what they're doing, again, they're picking choice 1 as that kind of like, fake answer, or like the fall answer, as I like to call it. So just be very, very aware, right? The angles stay congruent in similar triangles. The sides are what change. The sides are proportional, but you should never be dividing an angle in half or multiplying it by any ratio in a similar triangle question. The angles stay the same, only the sides change. And if you think about it, that kind of makes sense. Like the angle itself is not changing, right? Whether I draw it this big or whether I draw it really super teeny tiny, the angle that's formed by those two lines doesn't change based on how big or small my shape is. Or if you guys need to prove it to yourself, you can like take something and actually try to measure out that angle. And once you go through that exercise, you kind of like memorize it because it sort of makes sense, okay? Okay. Next one. We have directed line segment AJ has endpoints whose coordinates are 5, 7, and -10, -8. Point E is on AJ such that AE and EG is in a ratio of 2 to 3. Okay, so I'm a super visual person, so I would really recommend drawing out approximately what this looks like, right? We don't have to be perfect, but just approximately so we can understand where we are, right? So 5, 7, point A, let's say somewhere here, point A. And then we have -10, -8. Okay, let's say it's somewhere here, right? Not exactly, not to scale, but at least I have an understanding of what I'm dealing with, right? Okay, here's my line. Now I put point E, right, somewhere. And let's say I put it here, and that ratio here to here must be 2 to 3. Does that make sense? That's basically what the question is saying to us in a visual sort of way. Okay, what's my approach here? There's a few different ways that you can do it. We can use distance formula and see the distance between those sides, and then divide it into 5 pieces and then go 2. That's one way to do it. Another way to do it is to sort of guess approximately where we would be. So based on my not so perfect picture, it looks like it looks like I'm either going to be like still in the negatives, or if I drew it a little bit wrong, like we could also be somewhere here is my guess, right? Like depends on how you perfectly draw it, but definitely I'm not in these quadrants, right? Based on my picture. I'm probably going to be either in quadrant 2 or 3. So I know that either my value is going to be like negative, negative, or negative, positive. It's not really going to be 1, -1, because that would be this quadrant, and unless I really drew it bad. So just visually, like you can start testing some points that you think might be like, it's not going to be this. -5, -3, I think is also like a little bit too low. So I'd probably test like 3 and 4. That's another way to do it. So I just want to introduce you guys to many different methods, and I want to sort of show you like my logical reasoning and how I think through questions. I think that's a lot more valuable than just learning how to do these questions, because you can, look up any Regents explanations and do this on your own time. But the reasoning is really, really important, and it's valuable for future exams. Like when you guys take your SAT, that reasoning is much more important in those kinds of exams than on just the Regents. Okay, so how are we tackling this? Let's practice distance formula since we haven't done that yet. Who can give me the distance formula in the chat? Distance formula for coordinates, I meant. Yeah, good, right? So it's a giant square root. It looks crazier than it is. So to review the distance formula, it's x2 minus x1 squared plus y2 minus y1 squared. And this whole giant thing is in a square root. So it looks a little bit insane, but it's really not. It's kind of like Pythagorean theorem being solved for you already. So if you get intimidated by this formula, you can just think of that, and it kind of makes the intimidation less kind of scary, if that makes sense. So what is the point of this, right? So I want to figure out what the distance is of my whole line. Like, what is my distance between point A and J in this case, right? So you pick a point, any point to be your first point, your second point, doesn't matter. So let's call this like x1, and this will be y1, and this one will be x2 and y2. It doesn't matter which one you pick as your first or second, you get the same answer, okay? So now we plug in. So x2 is -10, x1 is 5. So -10 minus 5 squared plus -8 minus 7 squared, and the whole thing is square rooted. Okay, next, be really careful with your negatives, right? So -15 squared plus -15 squared, whole thing is square rooted. Does that make sense? Now we keep going. At this point, my negatives are going to go away because they're negative, right? And when I multiply negative by negative, they become positive. So now I end up with 225 plus 225. So now we end up with the square root of 450. Okay, how do I break up 450? Yeah. So you're going to think of, you have to think of perfect squares that fit into 450. So somebody in the chat thought of 50 and 9. That's fine. So we can say radical 50, radical 9. Radical 9 is just 3. So 3 radical 50. And then you think, can I break radical 50 further? And you can say 3 radical 25, radical 2. So it's 3 times 5 radical 2. So we end up with 15 radical 2. So that's our whole distance here, right? 15 radical 2. Then what we would have to do is divide that value by 5 to figure out, 1, 2, 3, 4, 5 pieces. And then once we have a fifth of that, we just multiply it by 2 and then figure out which point is going to be there. Does that make sense, sort of? Yeah, it's absolutely okay to use Pythagorean theorem if you don't like this formula. They're the same formula if you think about it. So this is kind of our long way of doing it. Another way to do it is to just test the values, like I said. So let's say we're going to test this point, right? -1, 1. So what we can do is we can now use the same formula and find the distance between -1, 1 and -10, 8 and -1, 1 and 5, 7, and make sure that those distances are in a 2-to-3 ratio. Does that make sense? So I'm gonna zoom in and do it up here for you guys so you can see what I'm talking about. So let's say that we're testing -10, 8, and we're gonna test -1, 1, and then we're gonna test -1, 1, and 5, 7. Again, you pick a point to be your x1, y1. So let's say this is x1, y1, this is x2, y2, and then we go to work, right? So we have x squared, x -1 minus -10 squared plus 1 minus 8 squared. This whole thing's in a square root. Be careful with your negatives. -1 plus 10 is 9. So this ends up being 9 squared. And this ends up being -7 squared. This ends up being 81 plus 63, which ends up being, plus 49. And 81 plus 49 ends up being radical 130. And then we do the same thing on this side. Again, you pick a point to be your x1, y1, x2, y2. And we do the same thing. So x2 minus x1 squared plus y2 minus y1 squared. The whole thing's in a square root. Here we end up with 6 squared plus 6 squared. So we have 36 plus 36, or radical 72. So again, these sides have to be in a 3:2 ratio, right? So 3/2 is 1.5. So if I take, radical 72 over radical 130, I should end up with that same ratio if that's my correct answer. Does that make sense? So that's how you would do this question. A little help of the calculator. I'm just gonna shrink this so we have space here. Okay, let's move on to number 11. So we have a tripping platform is used to unload trucks. Okay, and look what we have. We have an angle of 30 degrees. So we've seen this before. So what is this looking like we're going to have to use, right? This is 30 degrees. We have X, we have a right angle. They tell us that it's a 75 feet long ramp, right? So it seems like this is 75. And this is our X. So what do you guys think we're going to have to use here? Yeah, we're gonna definitely sine, right? Definitely our ratios. How would you describe 75? It's the hypotenuse, right? Good. So 75 is hypotenuse, and in reference to the 30 degrees, our x is opposite, right? So the ratios we're playing with are opposite over hypotenuse, which is sine, right? We learned sine is opposite over hypotenuse. The angle is 30 degrees, so we're going to have sine of 30 is equal to opposite, which is x over 75. Now, in this case, because we already reviewed the special right triangles, I want to push you guys to try to do this by hand, right? Like, what is the sine of 30? You guys should be able to sort of figure that out without a calculator, right? Let's review. 30, 60. Across 30 is 1. Across 90 is 2. Across 60 is radical 3. So the sine of 30 is what? Sine of 30 is what? It's 1/2, right? Good. So now instead of sine of 30, instead of plugging that into the calculator, we can just replace 1/2 is equal to x over 75. And now just by looking at this, you kind of know automatically that our answer is 37.5, right? Because that's going to be a half of 75. Or if you wanted to prove it to yourself, you could go ahead, we could cross multiply, we could prove it. We could say 2x is 75, divide both sides by 2, and we'll get the same thing. And again, you don't have to know this, right? You don't have to do the 30, 60, 90. You could just plug it in, but it's important to know these special right triangles. I promise you guys, they're going to keep coming up. So if you learn them earlier, if you haven't learned them in school already, it's just going to help. So let's review it again. This is our special right triangle. It's a 30, 60, 90 degree triangle. Whenever you have a 30, 60, 90 degree triangle, your sides are going to be in this ratio. Across the 30 degrees is 1, across to the 90 degrees is 2, and across the 60 degrees is radical 3. And these aren't necessarily values, like it's not necessarily like 1 inch or 1 feet, it's a ratio, right? So for 30, 60, 90, the ratio is 1 to 2 to radical 3. If you memorize this triangle, basically you have the sine and cosine of tangent of 30 and 60 degrees right there. And there's also a 45, 45, 90 triangle that has similar ratios that I want you guys to memorize. I'm going to draw it side by side just so we have it. And for the 45, 45, 90 triangle, the ratio is always going to be 1, 1, radical 2. And the 1, 1 makes sense, right? Because if the angles are equal, then the sides are going to be equal, right? It's an isosceles triangle. So these are two special right triangles that I recommend you guys memorize. these ratios. And if you memorize them, you know the sine, cosine, and tangent of 30, 60, and 45. You never have to use a calculator. And it's going to help you guys in trigonometry tremendously. It's going to help you on the SAT tremendously. Okay. Moving on, again, seems pretty familiar. We have a right triangle, MET, and then they draw out our height. And now they're giving us some values. So we have ME is 6, SM is 4, and they want MT. This is our X value. So what do you guys think about this one? How are we playing this game? They tell us the original one's a hypotenuse. Whenever we draw, the original triangle is a right triangle, right? They tell us that by giving us, first of all, they say in the question it's a right triangle, and then they give us that little symbol. You guys have to know that anytime you draw height, it must be perpendicular too. So we know that these are also right angles. So now it seems like we're going to be playing the Pythagorean theorem game. Right? So which sides can I figure out based on what I have? Yeah, we can find ES. So we're going to have 4 squared plus ES squared is equal to 6 squared. Going to have 16 plus ES squared is 36. Subtract 16 from both sides. And we're going to get ES squared is equal to 20. That means ES is radical 20. And I can fix it up a little bit, right? I can say radical 4, radical 5. So we can call it 2 radical 5. And then what would you do? Where can we go from here? So people are suggesting altitude formula. What is the altitude formula? Yeah, I would just do a proportion in this case. I think that's the easiest way to do it. So we would do MS is to, yeah, I would do that to MS over ES is equal to ST over ES. Or alternatively, we can try the altitude formula, which somebody is saying. So we would do 4 over 2 radical 5 is equal to 2 radical 5 over x. So we end up with 4x is equal to 2 radical 5 times 2 radical 5. 4x is equal to 4 times 5 or 20. Divide both sides by 4. We end up with x is 5. And we got ST exactly, 5. And now that we got ST, we can now play the Pythagorean theorem game to figure out ET. But we don't have to in this case because they just asked us MT. So now we have enough information to answer that. And the answer there is 9. Does that make sense? Okay, next one. We've got a square, and we have got two diagonals that intersect here, and they want to know which statement is true. So we have angle ACZ is equal to ZCH. So are these two angles equal? So this is choice one, right? I'm just going to draw it out and color code all the choices, and then we can talk about it. The next one is ACZ. So this angle is equal to ASZ. All right, so this will be 2 in green. 3AZC is equal to SHC. And then finally for AZC, this one, is equal to ZCH. Okay, sorry, I know the picture is confusing, but whenever you see diagonals of a square, you have to know that diagonals of a square are what? They're congruent, correct? And what else? One more word. Correct. They're perpendicular bisectors of each other. It's just a rule that you have to memorize. Right? They're congruent and they are perpendicular bisectors. Excellent. So whenever I see diagonals of a square, what I do is I draw this for myself. And then obviously we know that all angles in a square are right angles, right? So that kind of is an explanation for why our answer is 3. Diagonals form perpendicular angles, and obviously all the angles in a square are also perpendicular, or they're 90 degrees. Now, while we're on this question, let's review some other basic angle things that are commonly tested on the test. So let me give you guys a super easy question. What are the angles formed by two intersecting lines like this called? Yeah, vertical. So you guys need to know that all vertical angles are congruent, right? That's pretty easy. And then the other piece that's very commonly tested are perpendicular lines cut by a bisector. So let me label all these angles for us. We've got 1, 2, 3, 4, 5, 6, 7, 8. So who can tell me which angles are equivalent here? So I'll call out angles and you guys tell me based on what are they equivalent and are they equivalent. So 2 and 3. Congruent based on which principle? Yeah, same thing, right? Vertical angles, right? I just drew it a little bit differently. Okay, how about 3 and 6? Congruent based on what? Alternate interior, and then 2 and 7? Congruent based on alternate exterior, right? So angle 2 equals angle 3 equals angle 6 equals angle 7. So those are the relationships that you guys have to know. The way that I usually think about it is, remember that everything is alternate. So when we say alternate, we think of opposite sides of the transector, right? Opposite sides of that line. And then interior is inside the parallel lines, right? So if I draw it out for us, here are my interior angles, right? They're inside the perpendicular lines, and they're alternate because they're on opposite sides. So 3 and 6, alternate. They're on opposite sides of that diagonal. 4 and 5 are equivalent. They're opposite sides of that diagonal. right? So these would then be equal. And then alternate exterior is on the outside of those parallel lines. So if I draw it out for us, I'll highlight it in yellow. In this case, it's outside. And again, the alternate part comes from they're on opposite sides of that transector. So 1 and 8, exterior and alternate, 2 and 7, exterior and alternate. And then obviously 2 and 3 and 1 and 4, those are just vertical angles that we know. And then the other idea here is that the ones that are not equivalent are then supplementary, right? They add up to 180 degrees. So 1 and 2 are supplementary, 1 and 3 are supplementary, 1 and 6 are supplementary, 1 and 7 are supplementary. So any angles that are not equivalent here end up being supplementary. Does that make sense? And again, supplementary, I use this vocabulary, but it's really important that you guys understand this vocabulary. Supplementary means add up to 180 degrees versus complementary, which means add up to 90 degrees, excuse me. So here 1 equals angle 4 equals angle 5 equals angle 8, just to complete these notes. Okay, we're good? Okay, we've got some circle questions. So we haven't done a circle question yet. So we have circle O. We've got these secants. So secant is just by definition, it's a line that is crossing into the circle, right? So this is what we call a secant. In this case, CFD and CHE. They're drawn from that same external point C. And then they tell us that angle arc DE, excuse me. So this arc is 136 degrees. And this angle is 44 degrees. And then the measure of arc FH they want this arc. Okay, so we got to review circle rules a little bit. So what do you guys know about this? You guys are bad with circles? We'll review everything. Okay, so let's take a second. Let's do like a quick circle mini lesson because it seems like a lot of people struggle with circles. So again, the goal of this is not just to answer these questions, but to get you guys prepared for the Regents. They can ask anything, right? Here's a circle. Let's learn our vocabulary first, right? So usually they call the circle O. It doesn't matter what we call it, A, B, C, D, E. It doesn't matter, right? So circle is named for its center. This circle is going to be circle O. Now we've got different options, right? So we've got different vocabulary when it comes to circles, different kinds of things that they can talk about. So we have a chord. We've got a secant, which is what this question that we're working on is testing. We've got a tangent. And we've got an arc, right? That's most of the sort of vocabulary that they're going to throw at you. So a secant, which is what this question is testing, it's a line that goes through the circle and it contains a chord. A chord is a segment whose endpoints lie in a circle. So a chord is a segment whose endpoints lie on a circle. A secant is a line that contains a chord. So, for example, if we have this, I call this AB, that is a chord. And then if we've got this is a secant. So chord, secant. And then we've got a tangent. A tangent is a line in the plane of a circle that intersects the circle at exactly one point. And it's only at one point, right? So let's say we want to intersect at this point here. So this is what we call a tangent. And then an arc is just a part of the circle. It's the, like, not curly part, but it's the curved part. So it's the curved part of a circle. So there can be infinite amount of arcs. Chords create arcs, so do secants. So there's also this chord here, chord AC, for example. Okay, now that we did that, there's a few postulates that you guys have to sort of memorize. So one postulate is arcs. Arcs are just addable, right? We can just add them. So for example, like if I wanted to add this arc to this arc and I knew the measures of them, all we would do is we would add them. And you guys have to understand that the full circle is 360 degrees. So all the arcs must add up to 360 degrees. And then a half circle would then add up to 180 degrees, right? So all of that adds up. Now, the next idea is if a line is tangent to a circle, then that line is perpendicular to the radius at that point of tangency. So that is commonly tested. Let me draw that postulate out for you. That's not what this question is testing, but it's still important that you guys know this because they can ask. So if you have, let's say, this kind of figure, right? We'll call this point P, and they tell you PA and PB are tangents. What this postulate is saying is at the tangent point, these values are perpendicular to the radii. So what that means is that this is 90 degrees and this is 90 degrees. Does that make sense? So if a line is tangent to the circle, then the line is perpendicular to the radius at that point of tangency. So this is one thing that you guys have to sort of memorize. This is one theorem. I'll write it out for you guys. So if a line is tangent to a circle, then the line is perpendicular to the radius at point of tangency. So I've seen them, for example, what they could do is they can tell you that this is, let's say, 170 degrees, and they could say find point P. So how would you do that? Find angle P. How would we find angle P here? Yeah, right. So what you guys have to know is that this is what kind of shape. It's a quadrilateral, right? It has 4 sides, 1, 2, 3, 4. The sum of angles of any quadrilateral is 360 degrees, right? So sum of angles in any quadrilateral is 360. So by knowing that these are both 90 degrees, we would do 360 minus 170 minus these two angles also, right? Minus 90 minus 90. So it would be 360 minus 170 minus 180. And we would end up with 10 degrees for angle P as our answer. Does that make sense? So this is one way that they can test this theorem. So you guys have to know that whenever you have tangents, they create 90-degree angles with the radii. So that's one theorem that I want you guys to learn. Now, getting to this question, the second theorem, is that there's a relationship that happens when we have two secants that intersect at the exterior of the angle. So let's draw it out, right? So when we have a circle, like we have in the question that they asked, and we have got two secants, right? These are not tangents, right? Because they're not just meeting the circle in one point. These are secants. They're going through the circle in 2 points, right? Let's say A, B, C, D, and E. The relationship is that the measure of the angle formed is half the difference of the measure of the intercepted arcs. So the measure of angle formed is half the difference of the measure of the intercepted arcs. So the first theorem I gave you was for tangents. This is our second theorem of the day with circles. So for example, if we call this 35 degrees, we call this 125, and they want to know Z, right? Let's call that arc Z. The way that you would set this up is you would say, well, the angle, 35 degrees, is 1/2 the measure of the difference of the arc. So 125 minus Z. And then we just solve. So we'd have 35, or let's say we multiply by 2 on both sides, right? Just to get rid of that 1/2. End up 70 degrees is equal to 125 minus Z. I'm going to subtract 125 from both sides. And then we end up with negative 55 is equal to negative Z. So Z ends up 55 degrees. So this is the theorem we have to use to answer this question. Right? So I gave you different numbers for reason. Now let's use these numbers. So how would we set this up? Come on, guys. I promise I'm going to give you a break right after this. What did I just teach you? The measure of the angle is 1/2 the difference of the arcs, right? The measure of the angle, 44 degrees, is 1/2 the difference of the arcs. So 1/2, 136 minus x. Good. And then we solve, right? So that we did on the other page, we double both sides. We end up with 88 as 136 minus x. We subtract 136 from both sides. And what is our answer? We end up with x is equal to 48 degrees. Okay, so we learned there's more circle theories, but I don't want to inundate you guys, but that's why I only gave you 2, so you can slowly start developing your circle skills. But we always, whenever I teach a new thing, I always like to start with vocabulary because that's extremely important. Vocabulary is very, very important. We use it interchangeably in math, and you guys will get lost if you don't know what these different words mean, right? So secant, it's a line that goes through the circle, and it contains a chord. A chord is a segment. Tangent intersects only at one point, and an arc is that curved part of the circle that all of these things can form. In total, we have to know that the total degree in a circle is 360. Then just to review, we learned this theorem of any time you have a line that's tangent to a circle, it is perpendicular to the radius at that point of tangency. And I showed you guys an example of how that's tested. And then this theorem that the intercepted arcs, you subtract them and you take half of that, and that's how you get the angle that the secants form. So that's kind of the summary of our mini little circle lesson that we squeezed into this webinar. All right, let's keep going. Let's do one more question and then I'll give you guys a nice 5-minute break because I know these webinars can get long and I want you guys to be like, awake and active. Okay, we have a right circular cylinder which has a diameter of 8 inches and a height of 12 inches, right? So when you think about a cylinder, we've got a shape that looks like this, right? And the diameter is 8 inches. So that means that the diameter of my base is 8 inches. Again, vocabulary is important. Diameter goes completely through your circle. Diameter is 2 times your radius. So right away, my radius is 4. My height is 12, right? So from here to here is 12. Which two-dimensional figure shows a cross-section that is perpendicular to the base and passes through the center of the base? So imagine our base here is the circle, right? So I'm gonna highlight, these are my bases, right? So they want a cross section, like imagine this is an almost cylinder that I have on my desk, right? But let's imagine that it's a full cylinder. They want, if you take this and you chop it, right, all the way through, what am I gonna be left with? What kind of shape am I gonna be left with? You can kind of see from my picture, right? Like, what kind of shape am I going to be left with? Yeah, I'm going to be left with a rectangle, and that rectangle is going to be 8 by 12. Does that make sense? Based on the photo and based on the visuality of it? It can't be these because these would not be perpendicular to my base. That is my base. That would be parallel to my base. So I definitely know that it's not going to be a circle, so I can eliminate 1 and 2. And I'm picking between 3 and 4. And now I have to think, I'm cutting completely through, right? So it's not going to be 4. It's not going to be my radius. It's going to be my full diameter as I'm cutting completely through. You can try again, like with my coffee cup. Sorry, the background is like not letting me. Let me put it in front of my face. But if you imagine just taking this and cutting through, the thing that's going to be left is just a rectangle. Does that make sense? You're cutting vertically through the thing like a cross section. Okay, guys, excellent work. I'm going to give everybody a 5-minute break. We're almost done. We've got about 30 minutes left. I'll go 5 minutes over because we started a tiny bit late, but you guys take your well-deserved 5-minute break and we'll keep going. I'll see you all back at 6:35. Okay, you guys can go grab water, bathroom, stretch it out, whatever you need, and then we'll finish off strong for 30 more minutes. Okay, so we'll start back up 6:35. All right, guys, you can start coming back. I'll honor the 6:35, so you have 1 more minute of your break, but just calling you back so we start shortly. All right, guys, let's pick back up. So we're on number 16. We've got line AB. They tell us that it passes through the following points at -2, 6 on A and 4, 0 on B. And then they tell me that CD is AB after a dilation with a scale factor of 1/2 centered at the origin. And they want to know which equation represents line CD. So what's our thought process here? So what happens when we dilate a line? Does our slope change or does it not change? That's the main question we have to think about. I asked you a similar question with the similar triangles, right? When we So when we are going to dilate our line, what you guys have to understand is that the slope will not change. So for example, the slope here is 1, 2, 1, 2, right? 2/2 or negative up 2/2. So the slope here is basically -1, right? Does that make sense to everybody? I'm kind of doing that quickly in my head. I can break it down for you guys. So if we go from 1 point, right, we go up 2, so that's +2, left 2. So +2 over -2, my slope is -1. So a slope is a relationship, the same way an angle is a relationship. It's a ratio. Does that make sense? So when you're dilating a line, whether you're making it larger or smaller, that slope will not change. Does that make sense to everybody? So essentially, when I look through these answer choices, I see values where I have the same slope, and I see values where I've got a half slope. So the first thing that I'm thinking is, am I dilating the slope or not? And the answer is you are not, right? So we're picking between 1 and 2 because anything that's a ratio will not change. That's why the angles don't change, because both things end up going down, right? And then, as somebody else said, we can connect the 2 points to the origin like this. We can create our little triangle. And then we can, dilate it 1/2, centered at the origin. So we bring the line over here by half. And then we have a new line. But again, the ratio will not change. But what will change is the y-intercept. And the y-intercept is going to move from 4, it's going to go in half to 2. So our new y-intercept is going to be here. And the line is going to look, to the best of my ability, if I draw, it's going to look like this. But as you guys will see, the lines are parallel, right? So the slope will not change. Does that make sense? And that's why our answer here is -x + 2. So the slope stays the same way that the angles stay the same. But the line just gets translated. Does that make sense to everybody? Okay, let's move on. We've got in parallelogram ABCD with AC perpendicular to BD. It seems like their parallelogram is a rectangle, right? Based on what they're telling me. So we have A, B, C, D with AC, perpendicular to BD. A, B, C, D with AC perpendicular to BD. Sorry, they're telling me the diagonals are perpendicular. Okay, and then they're giving me the sides. We have AC is 12. This diagonal is 12, and this diagonal is 16. And they're asking me for the perimeter of ABCD. So how would you guys tackle that? So what do we know about diagonals of a parallelogram? So diagonals of a parallelogram, they bisect each other. So what we do know is that if this whole diagonal is 12, this piece is 8 and 8. Sorry, 12 divided by 2 is 6 and 6. And these pieces are 8 and 8. Right? And now we know that all of these are right triangles, right? Here's my right angle, right? If we just focus on one triangle. Here's one triangle, right? Here's the right angle. So yeah, now we can do Pythagorean theorem. The side that's missing is the hypotenuse. I know automatically this is 10. I want to teach you guys how I know automatically. There's something called Pythagorean triplets. Do you guys know this? Who knows the Pythagorean triplets? Again, this is extra. You guys don't have to know it, but I recommend it. So they're basically triplets that you can memorize, or you will memorize because they show up all the time. And by memorizing them, you just don't have to do Pythagorean theorem when you see them. So there are infinite amount of Pythagorean triplets, but I don't recommend memorizing, the infinite amount. I recommend memorizing the common ones, so that those are the ones that I'm going to give you. So 3, 4, 5. And again, the last one is always the hypotenuse because that's the largest. 5, 12, 13, 7, 24, 25. And the last one I would recommend is 8, 15, 17. I usually never see test makers go above these, but you memorize these, and then you learn that any ratios of these are true. So instead of 3, 4, 5, super common one that you see is 6, 8, 10, right? They just multiply this by 2. And that's what's here. 6, 8, 10. 6, 8, 10. 6, 8, 10, 6, 8, 10. Does that make sense to everybody? And now that we know that, then the last part becomes easy. It's just a perimeter, so all we have to do is we add everything up. So for number 17, our answer should be 40, or choice 3. Good. So the rule here that we have to memorize is that diagonals in parallelogram are perpendicular bisectors. Same thing that we reviewed for the square before. Same thing that we learned in that angle question before. Remember which two angles are equal? And it was the angle formed by the diagonals because it was 90 degrees, equivalent to one of the angles in the square, 90 degrees. Okay, let's keep going. We've got a triangle here, triangle CAT or CAT. Measure of angle A is 90. They gave us that visually. They drew in the altitude. Whenever you guys see altitude, I would draw in visually these right angles as well. And then they say which statement is always true. Okay, so we have CE is equal to AE, AE is equal to ET. Oh, awesome. So this is basically what we were reviewing before as well. So it's a repetition. So this is that altitude formula that we reviewed for the previous question. It came up right away, right here. Choice 1 is our answer. So CE is to AE as AE is to ET, right? Because AE is our altitude as they tell us, right, in the question. Okay, great. That one was nice, fast, and easy. Next one, we have a sandbox in the shape of a rectangular prism, has a length of 43 and a width of 30. Okay, so let's right? Not perfect, but here's our rectangular prism. And what they're telling us is that we got a length of 43 and we have a width of 30. Jack uses bags of sand to fill the sandbox to a depth of 9 inches. So let's say that, it's filled. Right, to the best of my ability. And this is going to be our 9 inches. And again, life hack is to check that all the units match, right? Inches, 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 okay? Each bag of sand has a volume of, 0.5 cubic feet. See, now they're flip-flopping the units, excuse me. What is the minimum number of bags of sand that must be purchased to fill the sandbox? Okay, so what are we doing? What do we have to figure out first? What would we do first here? So I would start with the volume. Let's figure out the volume. How do I figure out the volume of a rectangular prism? That's length times width times height, right? It's pretty easy. In this case, it's going to be 30 times 43 times just 9 inches because they tell us a depth of 9 inches. And we would use our calculator here, or you can multiply it by hand. So let's do 30 by 43 by 9. So we end up with 11,610 inches cubed. And now each bag of sand is 0.5 feet cubed. So how do I do this conversion now? What do I have to do? Do you guys want to convert 0.5 feet cubed to inches, or you want to do 11,610 inches cubed to feet? Which way you want to go? It doesn't matter. Both ways are going to give you the same answer. Okay, you want to convert inches to feet. Okay, so we're going to say 1 feet cubed is how many inches cubed? What's my conversion? This is where you have to be careful, right? You want to say 12 inches cubed. You have to be really careful because you have to cube the conversion, right? So it's not just 12 inches cubed, it's this cube must distribute to the 12 as well. Does that make sense? So really it's 12 by 12 by 12. So 1 foot cubed is equal to 1,728 inch cubed. And then we would say 11,610 inch cubed is our x feet cubed. This is the hardest part that kids mess up sometimes. Students forget to cube the conversion. If you're doing it in square, like square inches and just a 2-dimensional shape, you square the conversion factor. So now at this point, we just cross multiply. We get 11,610 is equal to 1,728x. You divide both sides by 1,728. So 11,610 divided by 1,728. We end up with x is equal to 6.71875 feet cubed. So now what do? We have this volume of feet cubed, and each bag is 0.5 feet cubed. So how many bags must I purchase? Right, this last final step is 6.71875 divided by 0.5. Which is 13.4, but I can't buy 0.4 of a bag, right? So whenever they say minimum, we always round up. Same thing that we saw in the other question, and in this case, it's going to be 1. The biggest takeaway from this question is the conversion. Please, please, please do not forget to square or cube that conversion whenever you're playing with units. And please, please, please when you are doing this type of work, just circle or underline whatever you have to do, annotate the question to make sure if the units are changing or not, right? And you saw in the other question, the units were stable. We didn't have to do this. But in this question, we went from inches to feet. So make sure that you're checking the units and then make sure what's the factor of the unit. So is it square? Is it cubed? And make sure that you are then squaring or cubing your conversion factor. That's the most common mistake here. Okay, moving on, we've got parallelograms, EATK. Okay, let's draw out our parallelogram. We've got EATK. Which information is always sufficient to prove that EATK is a rhombus? So what do we know about a rhombus? All sides are equal, right? It's like the parallelogram version of a square. That's kind of where I put rhombus in my head. So by definition, in a rhombus, all sides are equal, correct? Now, the diagonals of a rhombus are similar to a diagonal of a rectangle. So what we just learned, like EA being perpendicular to AT, that would show that it's potentially a rectangle, but that wouldn't prove like that it's a rhombus necessarily. Does that make sense? So this is saying EA is perpendicular to AT. So that's just telling me that it's a rectangle, right? If this is a right angle. That's not telling me that it's necessarily a rhombus. So not always sufficient, right? The key is always. ET equals AK, the fact that the diagonals are equivalent, again, not necessarily is that only true in a rhombus. That could be true if this was a rectangle as well. And then ET is equal to AT. That is not necessarily true in any of the cases, but EAAT, by definition, in a rhombus, all sides are equal. That's the key for this question. Okay, next one, number 21. We've got this diagram below. Okay, we've got parallel lines, which we've worked with before, right? I drew you guys out that diagram, so we might have to use some of those rules here. And then they tell us that BC is equal to BH. So I would just mark that on my diagram that these two are equivalent. As soon as you know that two sides are equivalent, you also know that these angles are equivalent, the opposite of them, right? Because as soon as you have an isosceles triangle, you know by definition that not just the two sides are equal, but the two angles are equal as well. Now, this gets a little bit crazy because we've got two bisectors, but if we just think about, right, these parallel lines, and if we just focus on this for 1 second, what do we know that is equal that I can mark on my paper? Well, I now know that this, right, by vertical angle would also equal this. I also know that this and this should be equal, right, by alternate interior. Does that make sense so far to everybody? Then this and this must be equal. By vertical angles. Does that make sense to everybody? And then this and this checks out by alternate exterior. Right? So far, everything that I marked in red should be equal. And then that means this piece technically is also equal, right? By vertical angle. So now let's see what they tell us. So they tell me that this is 62. And what do they want? They want PHK. So at this point, based on my diagram, this is my X, what they want. I already have enough information to figure it out. So I know this is 62 and this is 62. This is one full line, so it's going to be 180 degrees, right? So X is going to be 180 minus 62 minus 62. Does that make sense to everybody? So it's going to be 56 or choice 4. So two things that, okay, let me show you. So let's follow. I'm going to put a new color in, okay? So whoever's confused. So what they told me was that BH and BC are equal, right? You follow so far? From the fact that those two sides are equal, I know that this is an isosceles triangle, right? These are equal. By definition, when the two sides are equal, the angles opposite of them must be equivalent. So that's how I figured out that this angle that I'm now redrawing in blue matches this angle. And then from there, you now just play with vertical angles and alternate exterior interior. So this is equal to this by vertical. This is equal to this by alternate interior. This is equal to this by vertical, and then this one is equal to this one by vertical. And these are also equal by alternate exterior, right? So it all makes sense. And now that we know one of them is 62, I now know the rest of them are 62. Does that make sense? And we didn't even have to use the other line. You could have probably done the same exact thing on the other line, but I picked to work with this line because I knew that they gave us NCD. Does that make sense to everybody? Okay, let's squeeze in 3 more questions, and that's going to end our webinar today, okay? So we have triangles YEG and POM are 2 distinct non-right triangles such that angle G is equal to angle M. So we've got 2 triangles, not right. And we know that this is YEG, and we know this is POM. And what they're telling me is that this angle is equal to this angle. Which statement is sufficient to prove that these 2 triangles are congruent? So we want to prove that they're congruent. Okay, if I say that all the angles are equal, which is what choice 1 is saying, does that prove congruency? Choice 1. What does choice 1 prove? So all angles being equal just proves similarity, not congruency, right? We can have all angles being equal and the triangles don't have to be congruent. They're just similar. So not choice 1. We need at least something with the sides. Okay, next we have, we've got YG is equal to PM. Okay, so this side is equal to this side. And YE is equal to PO. Is that enough to prove that it's congruent? So now we have 2 sides are equal and 1 angle. Yeah, correct. I think that that is proving by side angle side. I agree. I agree. There is a sequence of rigid motions that maps E onto angle O and YE onto PO. So this is just angle and side. So, oh, but we also know other angles. So this is angle, angle, side. Is that a proof? Angle, angle, side? Yeah, angle, angle, side is also a proof. So I think that there must be a mistake in this one because I think there's two correct answers. Because the answer key is just saying 3, but I think both 2 and 3 are correct. Okay, so 2 by side angle side and 3 by angle angle side. Yeah, actually, you guys are right. This is just congruence. So somebody said angle side side is not a congruence. Also, it's specific because like these, so this is YG and YE, right? And this is saying PO and PM, but the angle of congruence that we have is not the angle between them. So that's kind of how they tricked you of why you can't use that theorem here, making the only correct answer choice 3. All right, let's finish up with the last two. So we have in a diagram of triangles ABD and CBE below, we've got sides AD and sides CE, which intersect at point F. Okay, and then they tell me ADB, so this angle, is equivalent to CEB. And then they want which statement cannot be proven. So what can we not prove? So let's check let's check choice one. ADB is equal to CEB. So can we prove these triangles are equal? So we have a side, right? We have AD and we have CE. So we have a side and we have an angle. Is that enough to prove that the triangles are congruent? So what can we prove from this picture, right? So from this picture, we see that we have vertical angles, right? So this angle is going to be equal to this angle. That's one thing that we know. It says cannot be proven. So two can be proven, right? EAF, can we prove that this angle, mark it in lighter blue, is equal to DCF? How would I prove that? So we cannot prove these two triangles are equal because for these two triangles, we don't have enough information. All we have is just side and angle, which is not enough, and that's why it's choice A. Does that make sense to everybody? All the rest of these, we have enough information to prove. Okay, and finishing off with the last one, we have a small town is installing a water storage tank in the shape of a cylinder. Here's my cylinder. It must be able to hold at least 100,000, right? So that means 100,000 or more. That's what at least means. Next, they tell us it must be exactly 30 feet. So the height must be 30 feet. 1 cubic foot holds 7.48 gallons of water. What is the minimum diameter that the water tank must be? So what's our volume formula for cylinder? It's pi r squared, our area, times the height. Does that make sense? So pi r squared is the area of a circle. We multiply all the way up by the height. So now r is going to be our variable. That's what we solve for. Height we know is 30. And we know that our volume must be 100,000 gallons. But I told you guys always check the units, right? So we've got gallons, we've got feet. So we've got to convert everything to feet. Does that make sense? So we have to figure out, well, how much cubic feet is 100,000 gallons? And this is not a common conversion, which is why they gave it to you, right? So first, let's do the conversion. So 1 feet cubed is 7.48 gallons. In this case, you don't have to like cube the conversion because they already gave you that 1 cubed foot is this much gallons, right? So you don't have to cube it. So now we just say 100,000 gallons is x feet cubed. And we solve, we get 7x equals 100,000. We use our calculator, we divide both sides by 7. 100,000 divided by 7. So x is 14,285.7 feet cubed. That's our new volume, right? So now we can plug that into volume. 14,285.7 is equal to pi. Radius is what I'm solving for, and height I know is 30, right? So now we divide both sides by 30, then we divide both sides by pi, we end up with radius squared is 151.65. They want to the nearest foot, so you use your calculator to just square root both sides. And we get our answer, which is 12.3, but they want us to round it, so we would just round it down to 12. All right, guys, so this is the end of our webinar. We got through the entire multiple choice section of the most recent Regents exams for geometry. So thank you guys so much for joining and spending the evening with me. I hope that you guys learned a lot. If you have any questions, I'm happy to stay later. If you guys want me to email you the notes, I'm putting my Kweller Prep email address into the chat. I hope to see you guys back for tomorrow's webinar. We're going to be doing chemistry tomorrow, and on Monday I'll be doing algebra. So I'd love to help you guys out. Come join our free webinars if you need any extra help with private tutoring, or later on with SAT or anything. I'm a long time Kweller Prep tutor, so I'd be more than happy to help. You guys are all free to go. Have a great night. Please email me. I'll send you a PDF of these notes if you want. And if anybody has any questions, you can stick around and ask me privately in the chat, or you guys can speak out, okay? Thank you so much. I hope that you guys learned stuff. Oh, you guys don't see the email? 1 second, let me just put the email to everybody. Here's the email for the notes. Thank you guys. Have a good night. Bye, guys. Just shoot me an email and say, hey, I was in your webinar. If you want the notes, please send me the notes and I'll reply back with the notes. I can't just send you guys the notes because this isn't like a class, so I don't have your email addresses, but what you can do is you can email me asking for the notes, and then I will just reply back with the email. Does that make sense? So again, I'm putting it in the chat. Thank you, guys.